It's a really easy question. I think what we're talking about is what's at the very edge.
Hello and welcome to the Edge Tech Podcast. I'm David Kozlowski. Alongside me today, I have Ant Newman, who is the Director of Content Marketing, and Pedro Oliveira, who is the Senior Solutions Architect at SpectraCloud. Guys, thanks so much for being on here today. We're going to be talking about Kubernetes at the edge. This is a topic I personally don't know a lot about, so we decided to kind of deep dive into it. I know a lot of listeners probably know what Kubernetes are, but can we just take a second to explain what they are in layman's terms so everybody can kind of understand as we continue?
Oh, thanks, David. I think so. Kubernetes. Kubernetes really is an orchestration platform and an orchestration way for you to manage containers. And containers basically are used for you to deploy microservices. So if you think about Uber, for example, and I like to use this analogy quite often, Uber has a lot of different things that you can do, like when you're ordering a car and you're selecting the way they want to do and your street, all of these things that you're doing, they are microservices and they're containerized. So that's the way that applications are built today with all these different microservices. So you actually, for an application, you actually end up having hundreds, thousands, even tens of thousands of different microservices that you have to manage and maintain. And what Kubernetes really does is it allows you to manage all these microservices in a declarative way. So it allows you to deploy all these different microservices into different types of environments. Could be in the cloud, could be on-prem, could be at the edge, which we'll talk about today. But that's what really Kubernetes is all about, is managing all these different microservices that you want to deploy into multiple different environments. And the great thing about these microservices, and the reason why we went this way, is because it allows you to basically make your applications really portable as well, right? So they're not dependent on where you want to deploy them. That's why also Kubernetes makes that a very good tool to orchestrate that, because then you can deploy your applications into multiple different places without having to be tied to the metal, to the hardware, or to a specific cloud.
You're saying two things I want to follow up on. So when you say services, can you give me an example of what these services are? You use the Uber one, but give me some more.
I mean, there's multiple different things that you can do. So, for example, when it comes to role-based access services, for example, so your application will have a way for you to log in and identify someone. That will be an example of a specific service that you can containerize and utilize that. It could be call outs to something else. So going back to the Uber example, so a one microservice would be Uber doing a call to Google Maps so that they can find your address.
Gotcha. Okay. So it's an instant that essentially happens. Yeah, in a sense. Okay. And when you say deploy them to different areas, what do you mean by that?
So you can deploy Kubernetes, and these Kubernetes clusters is basically what will make all of these microservices work together. Right? There's multiple different components. We won't get too deep into that. But these clusters, they can run in multiple different environments.
So every application's got to run somewhere, right?
Yeah.
Whether it's on a server in a data center you own, or in a cloud instance in AWS or Google, or on a little box at the edge somewhere, which might be, in a restaurant or under the trunk of your car. Applications run somewhere, and Kubernetes is part of the stack that makes those applications work. And it handles a lot of the stuff that applications need, like scheduling and connecting to networking, connecting to storage. It kind of sits on top of the operating system and your functions, and provides a lot of the stuff that modern applications need. And the two facts I like to give about Kubernetes: number one, it's basically the second most popular open source project after Linux. So, hundreds of thousands of users and contributors, and it's done this in 10 years. It's 10 years old. So it's still, by the standards of VMware or AWS, both of which are 20 plus years old. It's AWS's 20th birthday this year. It's a relative junior, and yet it's made such a huge impact because organizations and individual home users as well are seeing value in the way it does things. It's declarative, as Pedro said. It's API driven. It's highly modular, and it was built to be, was turned into a huge ecosystem of different modules of software that you can stick into it, whether it's for networking or for observability, for security. And that means everyone's experience of Kubernetes is different, but it's incredibly versatile, which means it fits to the kinds of applications and the kinds of environments and the kinds of organizational structure that adopters use. It's not opinionated.
Yeah. When it comes to like edge computing, I guess, like what are the benefits of Kubernetes in that instance? I mean, the Uber one I think makes perfect sense because it's on your phone, but what are some other elements, maybe more robust? So we're talking like an actual compute device.
Well, the thing, it's a difficult question to answer because, like I said, Kubernetes is different. There are different distributions of Kubernetes, just like there are different distributions of Linux. So you'll have incredibly strict down, hardened distributions of Kubernetes that sit in just a couple of 100 megabytes, are designed for small form factor hardware, have all their ports closed and services disabled, so they're secure and hardened, and they will run on edge boxes in manufacturing lines, whatever it might be. There are other, just like there are many different flavors of edge, there are different flavors of Kubernetes to go with it. So you might find a telco might describe something as edge that is really more like a micro data center, and in which case you've actually got plenty of power and cooling and hardware redundancy and all those other things. So Kubernetes is flexible, so it fits the different ways that people do things at the edge. It also includes things like high availability by default. So not only in terms of things like having multiple nodes forming a cluster for redundancy, but even things like if an application or a service fails, Kubernetes' whole point is that it schedules new ones. Like if your service crashes, it will start it up again, which, when you are in an edge environment running a relatively mission critical service, not having to have somebody go in there and manually do that, but the whole purpose of Kubernetes is to schedule jobs. So it's ideally designed for environments that need a degree of resilience.
Yeah, and that comes from the declarative nature of Kubernetes itself. And I think, again, it's the portability as well. So because for edge, everything becomes scale, right? And we'll talk a little bit about use cases, but it's not only about deploying it once or twice or three times. It's about deploying it hundreds of times, perhaps even thousands of times and tens of thousands of times as well. So, and then having that layer that orchestrates that deployment for you, it's also something that becomes very important. So from what Ant was saying as well about the resiliency and the declarative state and all these things that Kubernetes provides, it's also important on the operational side. How can you streamline all of these things for a large environment that you typically have to deploy for an edge?
You mentioned a minute ago around the hardware being utilized. Like how impactful or how important is the hardware to run Kubernetes?
Well, I mean, the importance of the hardware is totally down to the use case of the organization and the applications they want to run. You might have a relatively lightweight application and be running it on something as small as a Raspberry Pi. People have got Kubernetes working on that. Or you might be running something that requires, say, an intensive computer vision application for quality detection in a manufacturing line. And then you'll be using beefy accelerated hardware with GPU operators and local models. And then we do a piece of research every year called the State Production Kubernetes. I'm really seeing, compared to previous years, much more interest in hardware performance for workloads on Kubernetes. I think partly because the nature of edge is changing. Back when I started working in the world of edge, it was all IoT sensing, and I just need a sensor at the edge of the network and some wireless connectivity like Sigfox or LoRaWAN, and I would send some telemetry back to the cloud where the processing is done. Now we're seeing so much more workloads actually running at the edge. And that, I think, is driving the hardware discussion, is what are you trying to achieve in your edge environments?
Yeah, no, absolutely. And I think it's also, as Ant was saying, we're seeing different types of hardware for different types of use cases. So obviously with ARM now taking over quite a lot from x86 as well, and we see a big shift from different vendors and different technologies, like we see now NVIDIA coming out with a lot of the ARM stuff as well, even in their own products, both for edge use cases where we have the small jetsons that they have, as well as for the big Grace Hopper servers and all these things that they have. So I think that from a hardware perspective, as Ant was saying, it really depends on the different use cases, but also we have some of the vendors dictating what you can use. Like, for example, if you want to go with NVIDIA for their edge play, then you're kind of bound to utilize, for example, ARM. And running Kubernetes in ARM is quite different from running Kubernetes on x86. And this goes back to what I was saying around operationalizing Kubernetes for edge, which becomes quite challenging when you have all these different environments with all these different nuances, and how can you play around that from an operational perspective. So it's both exciting, and at the same time, it's something that we have to take care of. That's what we try to do with Palette and Spectral Cloud, is try to abstract away that complexity so that operational teams can deploy Kubernetes onto multiple different environments for edge or even on-prem, like I said, with multiple different servers and data centers that utilize different architectures in the same way that they would if it's running x86 versus if it's running ARM, for example. But that is dictating some of these nuances for the hardware. So hardware is still hard, as we were saying yesterday, but we still, again, trying to abstract away some of that complexity, and it's still very, very, very relevant.
Yeah. You guys wrote this paper you just mentioned a minute ago. What was the most interesting thing that you guys kind of saw from it? Maybe it's both of you have a unique viewpoint.
Yeah, I mean, from an edge perspective in particular, the standout stat for me, and we've been tracking this for a number of years, about a third of people use Kubernetes at the edge, or rather, I should say, a third of Kubernetes users do it at the edge, because we only ask people who use Kubernetes. This year, it hit 50%, big jump, and I think that combined with some of the other stats we saw around like what they find challenging about doing Kubernetes at the edge, a strong link to AI. And we don't want to make every podcast a conversation about AI. There's enough of them out there. But if you are trying to run inferencing workloads, for example, that are time sensitive, latency sensitive, or they involve high bandwidth stuff like sharing video feeds, you're moving large models around. You want to be putting that close to where the data is gathered and close to where the decision needs to happen, whether it's shutting down a production line or interrupting a safety situation in a warehouse. So I think for a lot of application owners, the choice of where they put their applications is biasing towards the edge in the age of AI. And we're seeing that feed into application platforms like Kubernetes, and the implication on the operations teams, the platform teams who build and run those environments for the application developers. Everything comes back to the application. So for me, that stat about big jump in edge adoption and the challenges are all shifting towards things like connectivity, performance, model management. It really shows the disruptive effect that AI is having on edge.
Yeah, that's awesome. Yeah. Would you agree?
No, 100%.
Yeah, it is crazy that I went up to 50%. What does that tell you about sort of, was there a particular industry that maybe is making the largest jump, or
it's kind of across the board, and it really mirrors what we're seeing in the work we do with our customers. We've got customers in manufacturing who are doing it in the the production line or in logistics. We've got customers in healthcare who are deploying in hospitals, clinics, pharmaceutical manufacturing lines. We've got a ton of customers in the retail sector, and particularly like quick serve restaurants, multi-unit restaurants. We've got customers that collectively have 100,000 restaurants, and they are all in on Kubernetes at the edge. And that's running things like kitchen management systems, point of sale, loyalty. They're using computer vision for detecting regulars or seeing when restrooms are being occupied for too long, where there might be a dangerous situation. It's basically the computerized box in every store, which might be franchise operated, so you need to ship it to the franchise. And that's happening at huge scale. And so, it's really every industry. There's defense and public sector as well, which is really investing in computerization at the tactical edge, where there is you need to be in a forward operating position where there is potentially network connectivity, or Kubernetes in submarines and on drones where they might be away from the data center and reliable access to the cloud for weeks or months at a time. And so having applications which are AI or not right there in the field supporting the mission it's just non-negotiable now. Everybody's doing it.
Yeah. And I think it comes back to AI driving this move onto not only bringing edge compute closer to where the use case is, but also as that happens, we need to figure out a way of actually deploying all these AI applications. And it turns out Kubernetes is actually very good at that because of the reasons we were talking earlier. So because Kubernetes makes it very portable and scalable for you to do so, it means that you can deploy all these different AI applications with Kubernetes onto multiple locations. And because Kubernetes is declarative and also scales very well, you can also build on top of that so that as you need more AI capacity and as your AI models are working harder, you can scale horizontally, for example. You don't actually need to, or vertically even, not horizontally, as the need grows. So you can build all these different nuances with Kubernetes, which is really good, right? Something that you couldn't do 5 or even 10 years ago when Kubernetes didn't exist. Everything was on bare metal, and it was much harder to do.
It sounds like though there's still obviously has to be some limitations or gaps that are happening, right? Like what do you think? Why is everyone not doing it? Like, and what is the challenges that we're going to face as it gets more complex?
We absolutely see this. Like the reality of developing a new platform is you build it in a lab first at small scale, and so you're sat there with some boxes wired up in front of you, and you're going, great, I've got a software stack, I've deployed it, needs to do an upgrade, needs to flash a new instance, whatever it is. The challenges with Edge are nothing to do with lab challenges. It's now I need to go from having 6 or 10 boxes or a pilot store or whatever it might be to, right, I've got 1,000 of these things. They are deployed in gas stations across the continent. And they all need upgrading at once for severity 1 security risk in one of the pieces of software. Or I'm having hardware failures because I have 2,000 devices and 1 or 2 of them will fail every day. And now you're into an economic situation of how much revenue are those services that are running on that box generating me that I can pay for engineers to go and swap the boxes out. Or I've got a box that I need to deploy at a franchise restaurant. Who's going to be on site to plug it in and set it up? I've got a box that's sat there in a restaurant staffed by 17-year-olds who have no IT security training, and that box is vulnerable to physical tampering in a way that my data center, cloud, or lab are not. How do I make sure that the workloads, the model, the hardware itself are secure against all these attack surface that's available on that device now? These are all problems that you need to think about at the edge that you don't need to think about in the cloud or in the conventional virtualized data center, where standing up a new instance or upgrading the connectivity is always there, the capacity is always there, and if needed, I can walk over and press a button. Like, none of those things are true with Edge, and you need to plan for all of those things if you're going to operationalize Edge at scale, without either completely running out of budget or delivering a terrible, terrible service because apps keep going down and not being fixed quick enough.
By deploying Kubernetes locally versus at the edge, is there any issues that you see happening? And does it make it more difficult, or is it just a simple process?
So the process itself is the same, but as Anne was saying earlier, the challenges are quite different. And it's interesting because we have customers that have been doing this edge and going on this edge journey with us for a while, right? So I would say for a while, 2-3 years, some of them. So there's things that you don't know until you actually find out the hard way. I mean, some of them we were discussing earlier is around how do you get the artifacts onto the edge device? Because sometimes when you're deploying all these different edge devices onto multiple locations, as let's say you're deploying Kubernetes and Kubernetes coming up, there's certain packages and things that Kubernetes needs to run. So if you're doing that in your laptop, in your data center, whatever, as Ant was saying, you always have bandwidth. But at some of these edge locations, most of the times you might have LTE, right? Or you might not even, you might have spotty connectivity, or whatever it is during that week. The internet's not so good. The ISP that is providing internet's having some issues. So,
And some of the packages can be gigabytes.
yeah, some of these packages can be multiple gigs. Typically, you'd see that for an edge deployment, we're probably talking around 5 gigs. Of course, we can make this much smaller, but usually with all the content and everything deployed, 5 to 10 gigs typically. So, that's considerable. And this is something that sometimes you have to take into account depending on the edge location that you're deploying to. So I would say that is one of the biggest challenges. I mean, we work a lot around that to actually make sure that it's all packaged and you can just deploy the edge device, and the edge device has everything that it needs to come up with or without connectivity.
Yeah,
Right.
It's worth noting that sometimes the connectivity isn't there by fact of life. It's a remote store with 2 bars of bandwidth, or it's on a 56K modem line. AOL's just switched that off. But sometimes the clusters are air-gapped by design. Yeah, like whether it's because they're in a defense facility or they're in a hospital. Maybe they're not connected to the facility's network because they are not owned by the facility. They're from a vendor or whatever it might be. And in that cases, you do need to have everything in the image or everything on a local content bundle that can be plugged into the device, and it gets everything it needs from there. But then it also needs to continue to operate locally without having to phone home to a cloud. So that kind of autonomous operation is something that probably a quarter to half of edge users have to design it. You can't rely on the connectivity being there.
Yeah. And you'll have, the thing about this is obviously you have that issue when you're bootstrapping the device initially. So once the device gets deployed, plugged in, you have to do it. But then every time you need to do data operations, like for example, doing upgrades, then you face this issue again and again and again. So you have to, again, operationalize for that. And it goes back to what Ant was saying. And in air gaps, sometimes that is someone walking in with a block of USB sticks and having to, plug them in and making sure that the device can take that over. And then everything else is automatic after that, right? So you're really trying to minimize the amount of work that people have to do at scale, because it's not about in your lab, as Ant was saying earlier, you're doing it with maybe 5-6 boxes. But in the real world, it will be hundreds of boxes. And I don't know about you, but plugging in 100 USB sticks, not that much fun.
Even where there is connectivity, like the field engineering burden of running large estates is huge. And so I know I work a lot with our product teams, and we're always coming up with quality of life improvements that are designed for the reality of how people do things in the field. So, for example, Kubernetes has lots of configuration files that are all in YAML, yet another markup language. And making a change on a device means going in and editing tons of YAML files. Instead, we've come up with a concept, something called cluster profile variables. You don't need to know how we got to that name, but the idea is that if you're changing an IP address or you're changing a configuration element, you do it once, and that gets rolled through all the configurations. Which means if you're, say, in a freezing cold dark factory and you're fat fingering IP addresses and you're making an error and you're wondering why the cluster's not coming up, that problem gets taken away. Things also like certificate rotations. So Kubernetes validates it's based on certificates for authorizations. Those expire on a regular basis, like 1 year.
Yeah.
So automating those means you've just cut out the need for a field engineer to visit that site every year, which is a truck roll, a guy in a van. The more of those sort of pain points you can identify and automate away, the better. Another example I'd give is upgrades. Pedro mentioned, whenever you say to somebody, what's your main pain point with Kubernetes? Upgrades. Everything on the device gets upgraded at least 3 times a year, for security, for feature upgrades, for deprecations. And there's a risk with any upgrade that it's going to fail. On an edge device, that's a huge problem if you're remote. So, so take the example of a connected device that's in a factory 1,000 miles away. You're pushing a major upgrade. It doesn't boot. You can't connect to the box. It's dead. What do I do? We've got a the idea of immutability, where you build an image that it's not upgraded in place. It can't be changed. It's immutable. We put that on the box. The box stands up. When you do an upgrade, what you're actually doing is putting a new version onto a second partition, completely new version. The box reboots and tries to load from that second version. If it fails, it stops and it boots back from the old version again, which we know to be working. So you've always effectively got a backup on the device, and then you don't end up with a bricked box where someone then has to drive 1,000 miles with a USB stick. So thinking about what are the real world scenarios for Edge where problems occur that cause you to put your head in your hands. Yeah, and try to work around those. Yeah.
You mentioned LTE and 4G. Like, does that solve some of these problems that you're talking about, like physically driving somewhere? Like, or is it something that you have to have a person there?
Yeah, I think it does solve that issue. But I think even in Kubernetes, going back to what Ant was saying, with Kubernetes having long-term support, what that means is you will be able to stay on a Kubernetes version for much longer, and you'll still be able to have support and all these things, and you'll have all these different applications and integrations that you're utilizing for networking, storage, and all these things. They will be maintained for longer as well for that particular Kubernetes version.
Although it's worth noting that LTS versions still come with patch releases, which means you're still having to do an upgrade.
Yeah, I think yes, but the point is you can stay there for longer, right? So you don't have a much shorter window of, I need to update every 3 months or every 6 months. You can actually update once a year or maybe once every 18 months, something like that. So my point is with LTS, with Kubernetes evolving and with these specific use cases around Edge and others, where you're deploying into a lot of different locations and you have to maintain that, then LTS or Kubernetes LTS is starting to come up the same way that you have long-term support for operating systems as well.
It might be worth just when the Kubernetes project was first getting popular, they released 4 major versions a year. And generally, like if you're on a service like EKS, EKS being Amazon's Elastic Kubernetes service, they manage the control plane, the brains of the cluster for you, and they will upgrade that to new versions of Kubernetes. And they have a support policy of N-2. So if you are not keeping pace, they start charging you more money if you haven't upgraded your clusters. The Kubernetes project switched a couple of years ago from doing 4 releases a year to 3 because partly the maintainers were struggling, but also the adopters were having a really hard time. There are breaking changes in every release, and there's always dependencies in the wider software stack that you need to test for. So just keeping on top of how the different software elements change over time is a huge burden for the teams that operate Kubernetes. It's one of the, its innovation is great and change is great as the project continues to grow, but the stability is what enterprises need. And coming back to Edge feels a lot more appliance-like. You buy a washing machine and you put it in your kitchen or your bathroom if you're European, and that you don't expect to do a software update 3 times a year on your washing machine. Similarly, if you're in oil and gas or you're in a restaurant, that point of sale machine, you don't want to be caring and feeding for it with 3 times a year or more often you're doing patches. Because every time there's a patch, there's a risk of, I can't take an order in my restaurant and my shift is screwed. So we need to get into that mindset of these devices are in the field for 3, 5, 10 years and they need to work.
Yeah, I think what's when I hear you guys talk about the gaps or the problems that exist, the simplicity in me says like, okay, well, we have devices that obviously have 4G LTE capabilities, which solves some of that, right? In really rural areas. Also, nano BMC to be able to control a device from anywhere if vPro goes down or something along those lines. And I think it sounds frustrating, I guess would be like the word. If you are managing hundreds of devices and you have to send a truck out there, I'd be furious. And it's costly, it's expensive, which brings the question, like, I think when you're talking about this journey, as you called it, in Kubernetes, like what would you say are the most frustrating parts that you find that you're dealing with and deploying Kubernetes at the edge?
From an applications perspective, it is a mindset difference as well, because you're deploying these microservices, which tend to be, we were discussing, right, cloud native in nature. So they tend to be used in the cloud. But from an application developer perspective, these also need to be resilient to be deployed into an environment that sometimes only has one box. It might have 3 in the case of Kubernetes if you have high availability, or even 2. We have an architecture where you can even deploy Kubernetes with highly available on 2 nodes. So it's not only on the operational side, but it's also on the application side.
Kubernetes is very sensitive to networking. All the different components of Kubernetes get assigned things like IP addresses. And if one of those components changes IP address, the cluster freaks out, can't communicate with it, everything breaks. And yet in the edge environments, a lot of the time, the cluster is being installed somewhere where you don't own the network. So we've got one example of a dental equipment manufacturer called Dentsply Sirona, a huge company. And all of their equipment is installed in dental offices. Right? That's where it works. But they don't own the dental office. They don't own the network. So you've got a scanner that scans the inside of your mouth. It's a Kubernetes cluster. And it's installed in a dental office where the receptionist or the cleaner might turn off the router and turn it back on again, giving the Kubernetes cluster and all of its components new IP addresses. At which point the cluster breaks. Dentsply Sirona gets a call from an angry dentist who can't use their cluster anymore. That's entirely because Kubernetes is expected to work in the data center where you are in control of networking. So we had to invent a new feature that effectively hides the real network from the Kubernetes cluster, and we call it dynamic network overlay. And it lets Kubernetes continue in its merry little world of knowing what its IP addresses are while the real network changes underneath. And this is all because Kubernetes was not invented for the edge. It just happens to be the best solution for the edge, but it doesn't mean it's perfect.
Yeah, it's interesting. You said that the dentist would be upset that their Kubernetes cluster wasn't working. I'm like, they probably don't know what that is. So
yeah, from their perspective, it's just, I can't scan people's mouths. What's going on? Why is my lock's not working? And then they're turning it on and off and
making it worse.
And
that's brings us to the whole point of edge is about applications.
Yeah.
Like you have an application, it needs to run somewhere. That may be in the cloud, it may be the data center, it may be a small box, but something needs to make that application work and provide all the scaffolding around modern applications like observability, like security. Kubernetes is the best answer for doing that, but it's complex and it's got all these challenges, and edge introduces a whole load of new challenges that you don't face in data center or cloud. And what we're finding with our customers is it's not killing their appetite for using Kubernetes at the edge. They absolutely are committed to it. We've found that in our research as well. But it doesn't mean they don't need help with making it work and making it work at scale, which is the single defining attribute of edge.
we touched on the buzzword AI, and I have to go back to it. What role does AI play in Kubernetes?
We asked about this in the research over the last couple of years, and reading some of the quotes from the interviewees, we did deep dive telephone interviews with them. There was a huge mix of, obviously the AI workloads is one part, but in terms of the AI for operations, I think a load of people are like, Kubernetes is really hard. I wish I could just press the magic AI easy button and it will tell me what's wrong with my cluster. How do I write this YAML? What should the right configuration be? How do I right size to make sure my utilization is good? How do I configure this? And they just expect AI to have the answers. There is also a huge amount of people who are skeptical of that, saying like, number one, it makes up stuff about the most basic questions you can ask. I'm a heavy ChatGPT user, but I wouldn't trust it as far as I could throw it. So why would I trust it to write YAML for me? That's one point. The other is there's a sort of just a general feeling, I think, in the platform engineering, SRE, DevOps world where that there is so much nuance and almost like human understanding that you need to do this well, that there's no conceivable world where AI will be running my clusters. Even if I could trust it to do basic stuff like writing YAML or diagnosing what a troubleshooting message is, we're talking here about people, we're talking about processes, we're talking about serving unique needs, having strategies, and it's not just about running an AI agent that tells me what button to press. So that whole, which comes back, I think, to some of the edge challenges we were talking about. But this is about field engineering. It's about end user experience. It's about thinking ahead for security risks, and just expecting an AI ops agent, ChatGPT style, to do that for me is like quite reductionist to the role of DevOps and SREs and platform engineers.
No, that's great. Look, there's obviously a lot to cover when it comes to Kubernetes and Edge, and obviously I'm getting the finger pointing that we need to wrap this up. So I'm going to start to close it out. But I have to ask, is there anything else that you guys feel like you'd want to call out when it comes to Edge and Kubernetes, or you feeling pretty good?
It's really feeling like it's growing in maturity. It's growing in mainstream adoption. More folks are experimenting, and just as importantly, more folks are going from experimenting to doing at scale. Coming back to the retail and restaurant customers we were talking about earlier, they're not just doing this in a pilot store. They're like, right, we've got 3 years to roll this out to 40,000 stores, or we're going to roll this out across all our franchise operations in EMEA. But this is not, the incubation arm or the accelerator team just messing about with the latest technology. Kubernetes is 10 years old. The vast majority of users, right or wrong, call it mature, and they think this is ready to run business critical workloads on at the edge. So that if you're not already paying attention to Kubernetes for your edge projects, I guarantee your business has got edge projects, whatever sector you're in. And Kubernetes seems to be the market choice. So if you're not already thinking about it, you probably should be.
Awesome, guys. Pedro and thanks so much for spending time with us today. And thank you all for listening to the Edge Tech Podcast powered by SNUC. I'm David Kozlowski. Take care.